Hello everybody, this is Damon Betleon. In this video we're going to find the true length of a line. Now we first need to understand what these projections are of these lines, and physically it would be like looking at a line at an angle like this. We don't necessarily know what angle, but it's at an angle. It's not necessarily in its perfect state where we can look directly at it, which is what we're trying to find here. We're trying to find the true length, where we're looking directly at a line so that we can see the actual length of it. Because right now, the length of these lines does not perfectly represent its actual length. So, in order to find this, we would physically make a folding line. Let's say it's at an angle here. We would make a folding line parallel to it, so that it would then be folded around it, and we would look directly at that plane that it was folded around, such that it would make it the true length of the line. Now that might be a little hard to understand there, but if we yet again compare this to our auxiliary view, let's now look at this line right here, the part of this dovetail. Now, here's our one folding line. Transferred across it would yield this line just going from here to here. Now, what we did was make a folding line that is effectively parallel to this line here. And so, what we get is this line here in its true length. So now, to bring back our problem, what we would first do is what we usually do. I'm just going to connect our two projections of the lines with our projection or guidelines. These should be, in the problem, already sort of given that it would be perpendicular there. And then the next thing that I'm going to do here is make a folding line parallel to one of these lines, one of these views of the lines. I can do this with either line. It will give me the same result. So, now I'm just going to eyeball this. But, actually no, I'm not going to eyeball this. Let's do this the right way. So, looking here, it doesn't matter how far away you make this folding line, excuse me, as long as it is parallel. So I will hold that there, such that I can make a line there. Let me get that back out. So there's your folding line. On this side it's F, plane F, and I'll make this plane 1 over here. Now, as we did with our typical point transfer problem, we will transfer projection lines across our folding line such that it would be perpendicular to our folding line. Boom. And extend that. And now we do the same thing. We take our distance here, and that directly relates to the distance here across two folding lines. Same thing. Back here directly relates to here. So there's my 2 points. If you connect the 2 points, you get a line. And this would be B1, and this would be A1. This line is our true length. What we did to get here is we just created a folding line that is parallel to our lines, such that when we project the line over to that plane, it will give us the true length. And a way that you could check your answer is if you use your dividers and just get the length of that line in them. This should every single time be longer than each previous projection of your lines. If you don't have this, you made a mistake. And the reason this works is just for the simple fact that, yet again, the true length means you're looking directly at the line. You can see the true length of it. Every other of these projections is just looking at an angle. True length looks directly at it.